In this video, we are going to discuss few problems on scalar potential. First problem, prove that f vector 2x plus yz into I vector plus 4y plus zx into j vector minus of 6z minus xy into k vector is solenoidal as well as irrotational. Find the scalar potential phi such that f vector equal to del phi. In this problem, first we are going to prove the given f vector is an irrotational vector and also solenoidal vector, and then we can calculate the scalar potential phi from this f vector equal to del phi. Okay, we know that the condition for solenoidal and irrotational, solenoidal condition is del dot f vector equal to 0, irrotational condition is del cross f vector equal to 0. Okay, first we are going to prove del dot f vector equal to 0 and del cross f vector equal to 0. Del dot f vector equal to, first you write the expansion of this del I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z dot f vector. Given f vector is 2x plus yz into I plus 4y plus zx into j minus of 6z minus xy into k vector. Okay, now we are going to multiply these two terms. Taking dot product for these two terms, we will get I vector into dou by dou x of 2x plus yz. This into this means I dot I value 1. Here there is no I. Dou by dou x of 2x plus yz plus second term into second term j dot j value 1, we will get only dou by dou y of 4y plus zx, and then third term k dot k value 1 plus dou by dou z of, this negative sign is common for both, taking inside it will be minus 6z plus xy. Okay, now we are going to differentiate one by one. Dou by dou x of 2x plus yz is 2, because differentiation of 2x is 2, yz will be constant, plus dou by dou y of 4y plus zx, here there is no y, the second term, it is 0, it will be 4, plus dou by dou z, partial derivative with respect to z, minus 6z is there, we will get here minus 6. Second term will be 0 because there is no z. It is equal to 2 plus 4 minus 6 will be 0. Okay. Therefore, the given f vector is solenoidal. First condition. Second one, irrotational. Del cross f vector equal to, we can write. First, we are going to write the general determinant. Write in the first row I vector, j vector, k vector. In the second row, write the del elements. First term is dou by dou x, second term in del dou by dou y, third term will be dou by dou z. Third row values are f vector elements. In the first term, 2x plus yz is there. In the second term, 4y plus zx is there. In the third term, minus 6z plus xy is there. First we have to write the determinant value in this, and then now we can expand the determinant in the as usual way. Now we are going to expand this one. I vector into dou by dou y of this, dou by dou z of this. Dou by dou y of minus 6z plus xy. In the cross you have to add one negative sign. Dou by dou z of 4y plus zx. Okay, first term. In the second term, here also you have to add one negative sign, minus j vector into dou by dou x into minus 6z plus xy in minus dou by dou z, this into this, dou by dou z of 2x plus yz plus k vector into this into this, this into this, dou by dou x of 4y plus zx minus dou by dou y of 2x plus yz. Already you know very well how to expand the determinant. I vector into dou by dou y of mean there is no y here. Here y is there, y will be 1, we will get only x. Dou by dou z, there is no z in the first term, 0. Here z is there, z will be 1, we will get only x. Here one negative sign is there, which is minus x. Minus j vector into dou by dou x of this one, first term 0. Here x will be 1, we will get only y. The second term, dou by dou z of 2x 0, here z will be 1, we will get y, which is minus 1, plus k vector into dou by dou x of this mean there is no x here, which means 0, dou by dou y z, here zx will come, here not only z, zx, which means here differentiate with respect to x, will get z, x will be 1, will get here first term 0, minus differentiate with respect to y, y means first term 0, y will be 1, here we will get z, here negative sign is there, minus it. Now we can remove these terms because opposite sign. Now we are getting here del cross f vector equal to 0. Now we proved the given f vector is an irrotational vector. Second condition also we proved. Now we are going to calculate the scalar potential phi from the f vector equal to del phi. F vector equal to del phi. First, f vector is nothing but our given equation, which is 2x plus 2yz into I vector plus 4y plus zx into j vector minus 6z minus xy into k vector equal to, write the expansion for this del phi. I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Now we are going to equate the terms. First term, ith term, which is dou phi by dou x is equal to, we can write 2x plus yz. And then equate the second term both sides, which is dou phi by dou y equal to 4y plus zx. Third term will be dou phi by dou z is equal to minus 6z plus xy, because this negative sign is common for both. Okay, from these three equations we are going to find the phi. Okay, now from the first equation we can write the phi value here. If we differentiate, integrate with respect to x, we'll get phi. Integrate with respect to x, right hand side also 2x square by 2 plus yz into x will come plus f1 of y comma z. Because here we are integrating with respect to only x only. Here y and z are constant. That's why we are writing in this form. In this equation, integrate with respect to y. If we integrate with respect to y in the left hand side, we'll get here pi. Right hand side 4y square by 2 plus zxy plus f2 of x comma z. Because in this equation we are integrating with respect to y, which means here x and z are constant only. Now from this equation, if we integrate this equation with respect to z, we will get phi. Phi is equal to minus 6z square by 2 plus xyz plus f3 of x comma y. Here x and y are constant. Now we are going to write the phi from these three equations. The 2 cancel, we will get x square plus here xyz remove plus 2y square plus xyz already written here, don't write it the repeated terms here, plus here which is minus 3 means minus 3z square plus xyz is there already written, don't write the repeated terms, which is the required one. From these three equations we have to write the final scalar potential phi, okay, which is the required answer. Okay, next problem. Prove that f vector equal to y square cos x plus x cube into I plus 2y sin x minus 4 into j vector plus 3x z square into k vector is irrotational and find its scalar potential. In step 1 we have to prove the given f vector is an irrotational vector and then we can calculate the scalar potential phi. Okay, we know that the rotational condition del cross f vector equal to first row elements are I vector, j vector, k vector. Second row elements are del elements dou by dou x, dou by dou y, dou by dou z. Third row elements are f vector elements. Write one by one these three terms. Y square cos x plus x cube 2y sin x minus 4. The third term will be 3xz square. Okay, now we are going to expand this determinant. I vector into dou by dou y of 3x square z square, which means partially differentiate with respect to y. There is no y here, which is 0. Minus dou by dou z of this one, there is no z here, second term also 0. Minus j vector into dou by dou x of this one. Dou by dou x of this one, x will be 1, we will get 3z square. And then minus dou by dou z of this one. In the first term there is no z. In the first term there is no z. In the second term, which is z cube. Z cube is there. Differentiate with respect to z, will get 3z square. Plus k vector into dou by dou x of this one. There is no x here, which is 0. Differentiate this one. There is no y here. Dou by dou y of dou by dou x means here x is there. 1 second. 2y sin x is there. Here 2y sin x, which means 2y into differentiation of sin x is cos x. Minus 4 will be 0. Now differentiate with respect to y here. Here y square is there, minus 2y cos x constant as it is in the given form. We can write next term is here. Okay, now we can remove plus 3z square minus 3z square. This term also 2y cos x minus sin. Now we are getting del cross f vector equal to 0. Therefore, the given f vector is an irrotational vector. First part we proved. And now we are going to find the scalar potential phi from this f vector equal to del phi condition. First you write clearly given f vector, which is y square cos x plus z cube into I vector plus 2y sin x minus 4 into j vector plus 3x z cube into k vector equal to del phi. Write the expansion for del phi. I vector into dou pi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Okay. Now we are going to equate the ith term, jth term, kth term, both sides. Now we can write dou phi by dou x is equal to y square cos x plus z cube, and then dou phi by dou y equal to 2y sin x minus 4. Then we can write dou phi by dou z is equal to 3x z cube. Now we are going to integrate one by one. First integrate with respect to x, we will get phi in the left hand side. Right hand side y square into the integral of cos x is sin x plus z cube is there plus z cube into x will come plus f1 of y comma z. Here integrate with respect to y, phi is equal to 2y square by 2 into sin x. Here sin x constant minus 4y. Okay. Plus f2 of x comma z. Here x and z are constants. Now integrate with respect to z, we'll get phi in the left hand side. In the right hand side 3x into z cube. Here z square, not z cube. This one is z square. 3z cube by 3 plus f3 of x comma 1. Okay, from these three phi value, we are going to write the final answer. Phi is equal to, from the first equation, you write all the terms, y square sin x plus z cube x plus, from the second equation, here also y square sin x is there. Already we written here, you don't need to write it again. This one. Next term will be minus 4y. 3 cancel. Here x z cube is there, already written here. From the first term already written here, don't write it again. That's all. Plus c, we have to add one constant finally, which is the required scalar potential phi. Okay. Here also